Hello, good afternoon students. Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. How are you all? Today we are going to discuss about structure of atom, NEET most expected questions. Welcome to 10,000 most expected questions from the NEET series. How are you all doing? Can you all able to hear me? Wonderful. So today's students list, okay. So those students who are regularly attending the classes, it is really appreciated and all the best. And today's vote is going to be crack your NEET examination. For that, I suggest every student please attend the class on the regular basis and please like the session, share with your friends. Hemant, hello, good afternoon, and subscribe to Infinity Lane NEET channel. Rahul Prabha, okay, and expecting Maunika too. Yes. So, so far we had NEET NCERT Express. All the topics from various chapters has been completed. After that, we are in the journey of 45 days. In these 45 days, every day I am coming to one topic and assorted multiple choice questions related to the NEET examination is going to be discussed here. In this discussion, students are also actively participated. As Monica, hi, how are you? And in today's class, so far practical organic chemistry is completed and chemical bonding is completed for a couple of sessions, and periodic classification of elements is completed. Good afternoon. And today we are coming up with the structure of atom, part 1. So in this we will discuss so many things, question and concept and how to solve the question and simple tricks and tips to solve such type of questions. Many things. Huria Abdul, hello, how are you? So while let's see SEO test preparation, maybe any examination that you prepare. Aishraj, hello. And in Google Play Store, Infinity Learn app is there. You all can click it and you can enjoy live classes, mock test, create your own test and 24/7 doubt resolutions. And without delay, I just want to put into your concept structure of atoms. What are the actual topics that you study in the structure of atoms, like fundamental particles, Rutherford model, and nature of light, photoelectric effect, and Bohr's theory, and hydrogen spectrum, de Broglie concept, Heisenberg uncertainty principle, and Schrodinger wave equation, and quantum mechanical model, and shapes of orbitals, and finally electronic configuration. These many topics are there. You are going to get a question definitely from this particular chapter. I want to take 2 sessions to conclude various models and various topics from these. So are you there, right? So Daya, hello. So let us give these many topics. Among these many topics, let us segregate what are the best important topics. So nature of light, photoelectric effect, Bohr's theory, hydrogen spectrum, and quantum mechanical model. And in that you just see the quantum numbers as well. So 1, 2, 3, 4, 5 major topics. If at all you are going to get a question, you will get it here, right? So where you want me to start? Direct question or little bit formula revision? Option is yours. Option is yours. As you say, Maunika, Rahul Prabha, Hemant, hello. Abdul. So it's a live interactive session. Daya Hriday, it's a live interactive session. You can give response immediately, so that depending upon your requirement, I am going to deliver the lecture. At the end, you are going to get a super important questions. Formula revision, Monica, okay, direct questions, jump into the questions, okay. So mixed matching opinions, okay. If we discuss just formulas for a whale, yeah. So mixed matching, majority of the students is asking about formula revision. So it would be good even once you start a topic in directly, instead jumping into that, we can just go for a quick revision of about the formulas, okay, not less than 3-4 minutes, okay. Now let's talk about structure of atom, in that the radius of the nucleus in the range of r naught a to the power 1 by 3, right. A is the atomic mass number, it is in the centimeters. Okay, this is derived from the Rutherford atomic model. And also Planck quantum theory, light is in the form of discontinuous energy packets called quanta, and each quanta has certain amount of energy associated with. Turn questions, just a minute Hemant. So as students, other students are also requesting, please be patient, I understand, okay. So the energy of one quanta or photon is equal to h nu is equal to hc by lambda. Nu is frequency, lambda is wavelength, and c is velocity of light, 3 into 10 power 8 meters per second, and h is equal to Planck's constant, 6.626 into 10 raise minus 34 joule second. And also photoelectric effect, when a light is allowed to fall on the surface of the clean metallic surface, ejection of electrons takes place from the surface of the metal, and the phenomena is known as photoelectric effect. And the photoelectric effect is given by Einstein, and it is going to be energy of the incident light is equal to h nu naught plus half mv square. So nu naught is equal to threshold frequency, nu is equal to incident light frequency, and mass of electron, velocity of electron. You can also say E is equal to W naught plus Ke, you can also say like this, or otherwise you can say Ke is equal to h nu minus h nu naught. So Ke is equal to h of nu minus nu naught. So the various forms of equations you can see. And also Bohr's model of hydrogen-like atom and hydrogen atom and hydrogen-like atom. Bohr's theory is only applicable for hydrogen and single electron species. And it talks about electron revolve around the nucleus in a concentric circular path is designated by KLMN, or n is equal to 1, 2, 3, 4. So as long as the electron revolving around the nucleus, electron in a shell has some energy, and that energy is fixed. So these shells are called stationary shells. So if energy is given, a lower energy electron can be jumped to higher energy shell, and the amount of energy, that is delta E is equal to E2 minus E1, and it successfully explains the spectrum of hydrogen. So let's talk about angular momentum is quantized, mvr is equal to nh by 2 pi, n is equal to shell number, and also En, energy of the electron in nth shell, is equal to minus E1 upon n1 z square upon n square, and it is also given as 2.18 into 10 power minus 18 into z square by n square, and joule per atom, or otherwise we can say minus 13.6 into z square by n square electron volts. So these formulas is very important, and it is good to revise before we start answering questions, right. And also E1, E is equal to minus 2 pi square me to the power 4 by n square into radius of the nth shell. Okay, so this expressions can give you insight in multiple choice questions, right. In angstrom units, radius is equal to 0.529 into n square by z angstrom units. So energy and radius, based on you are going to get questions. So I am giving you where you are going to see the question. So otherwise you can say velocity of the electron is given as 2 pi z e square by n, and it is given as 2.18 into 10 power 6 into z by n meters per second. And also you can see E2 minus E1 is equal to delta E is equal to hc by lambda, right. CUET exam, Abhishek, this is the NEET channel beta. Okay, so you can also calculate hydrogen spectrum ka formulas bhi hai. Okay, so I am coming to that. So de Broglie wavelength electron and any particle under motion will have the wave behavior as well as a particle behavior, and the wavelength is inversely proportional to its momentum. So lambda is equal to h by mv and h by p, and lambda 1 by lambda 2 is equal to p2 by p1. P is a momentum, right beta? And also wavelength of emitted photon is going to be 1 by lambda is equal to nu bar is equal to r z square into 1 by n1 square minus 1 by n2 square. What is r? Abhishek Kumar, Hemant, you tell me what is r? R is equal to Rydberg constant. Beta, R is equal to Rydberg constant. It is going to be 109,677.8 centimeter inverse, right? And you can also say 1 by R value is equal to 916 angstrom units. So this can help you. This can, yeah, Rydberg constant, Megharai. Hi Megharai, how are you? Yeah, Rydberg constant. So you can use this trick when you solve this direct wavelength calculations, right beta? And also number of photons emitted by a sample of hydrogen atom or hydrogen species. So maximum spectral lines is equal to delta n into n plus 1 by 2, or otherwise, yeah, 912 angstrom units. 912, 916 कुछ फर्क नहीं पड़ता है हेमंत, let it be, right? So maximum number of spectral lines that can be formed is equal to n2 minus n1, n2 minus n1 plus 1 upon 2. So this is very important. When electron is coming to n is equal to 1, you can directly use this. Otherwise you can say higher shell is equal to n2, a lower shell is going to be n1, n2 minus n1 of n2 minus n1 plus 1 by 2, and this is going to give you a maximum number of spectral lines. If anything specifically asked, you have to do manually. You directly don't have this formula, right? And Heisenberg uncertainty principle. Subatomic particles like electron, for it, exact position and exact momentum of the subatomic particles like electron cannot be determined accurately and simultaneously. If you do so, you will get an uncertain values. And that uncertainty delta x dot delta p should be greater than or equal to h by 4 pi. Mean to say it should not be less than. Okay, proved mathematically. And delta x is equal to uncertainty in position, delta p is equal to uncertainty in momentum. Uncertainty in momentum is equal to delta x delta m delta v, because mass is certain. Mass you don't have uncertainty, mass is always a certain value, right? Now let us see quantum numbers. So far, if you take a last decade, 8 times the questions are asked from quantum numbers. So that is the importance of this quantum numbers, bacho. So to designate the electron in an atom, a set of 4 quantum numbers are required. That is first principal quantum number. It signifies to which shell an electron is related. So that is designated with n, and it is proposed by Niels Bohr. Whatever the Bohr's theory you study is all about the quantum number, principal quantum number. Hi Hirakan, and it is having the values 1, 2, 3, 4 till infinite number. N cannot be 0, right? There is no 0 shell, right? Now here next orbital angular momentum of the electron in any orbit. So this is all about azimuthal quantum number. So let us talk about the azimuthal quantum number. So that is L. So this azimuthal quantum number can explain the fine spectrum of an hydrogen. It designates to which subshell an electron is belonging. So its value is going to start from 0 and 1, 2, 3, 4. It goes on like that till n minus 1. ज़्यादा से ज़्यादा L का वैल्यू n-1 तक होगा. सो L का वैल्यू n का वैल्यू कभी बराबर नहीं होगा. ठीक है बेटा, L वैल्यू कैन नेवर बी इक्वल टू n वैल्यू. सो L वैल्यू 0 से शुरू होगा. ओके, if L is equal to 0, okay, it indicates S subshell L is equal to 1, P subshell L is equal to 2, D subshell L is equal to 3, F subshell. So electron revolving around the nucleus in an orbital, the orbital itself has some angular momentum that is called orbital angular momentum. Okay, so this is angular momentum, not an orbital angular momentum, right? So angular momentum, orbital angular momentum नीचे आएगा आपको. And azimuthal quantum number, we already mentioned, it is 0, 1, 2 till n-1. And number of orbital in a shell is equal to 2l plus 1. So before this NEET, we have said AI PMT examination, there this particular question has been asked. And also maximum number of electrons in a particular subshell is equal to 2 into 2l plus 1. So मैं क्या पूछना चाहता हूं आपको, मैक्सिमम नंबर ऑफ इलेक्ट्रॉन इन ए शेल कितना होगा, कितना होगा बोलो जल्दी. हेमंत, दिस इज क्वेश्चन. मैक्सिमम नंबर ऑफ इलेक्ट्रॉन इन ए शेल, ऑर्बिटल एंगुलर मोमेंटम इज इक्वल टू nh/2π. ओके, मैक्सिमम नंबर ऑफ इलेक्ट्रॉन्स इन ए शेल, आंसर क्या होगा, 2n². 2n², n is equal to principal quantum number. Maunika, and maximum number of electron in an orbital, is equal to just 2. Any orbital it is 2, mind it. n², 2n². Shell में 2n² आएगा. Okay, and here maximum number of electron in an orbital is 2. Okay, and orbital angular momentum is given as root over L into L plus 1 dot h/2π. Okay, so this is about the summary of the quantum numbers. So let us go into the topic questions. Ready for that? So whenever you are attempting the questions from any chapter, let it be physics, chemistry and biology, my suggestion is let us go through the summary, then start doing. Rectified? Very good. That's why I wanted to recall all the formulas. So these formulas are there with you. So in the Telegram channel, I just want to give you all formulas, this same lesson notes in the PDF form. Everybody get into that. Okay, so let's go into the questions, and today and tomorrow also we'll do. आप आज जितना तक कर सकते हैं उतना तक कर लेंगे. ओके, कल बाकी क्वेश्चंस करने का तैयार है. शुरू करना पहले क्वेश्चन का आज. Well, now let's talk about increasing order of E by m values of alpha particle, proton, electron and neutron. Specific charge, E by m value और क्या बोलना, specific charge. आपका आंसर क्या होगा? Use the chart box and I want to see what answer you are giving. Hira and Megarai, Maunika, Hemant, I want you just intensify your answers now. Okay, you want to say 444? Wide. Very good. So, E means charge, M means mass. So, charge upon mass. So, let us talk about N, alpha, proton and electron. है ना? न्यूट्रॉन का चार्ज 0 है and mass, okay, is going to be 1 unit, and alpha particle का charge 2 units का है and mass is going to be 4, right? Proton का 1 and 1, and here it is going to be 1 unit charge and less than 1. value of the mass of the electron is less than 1. So, it is negligible, I know 1 by 1837. So, you take 1 by 1837, it is 1837 is the answer, right. Now, it is going to be infinity, it is going to be 1 by 2, it is going to be 1, and it is going to be greater than 1. Okay. So, here the answer is going to be n alpha Pe. So, it is going to be 0. It is going to be 0 beta. It is going to be 0. So, 0 is greater than half is greater than 1 and it is going to be greater than 1. Understand? Clear? That's a very good answer. Fundamental particles के हिसाब से क्वेश्चन पूछा गया and it is a stock question. Maunika, it is 1. Now, its answer is going to be 4. It is going to be 4. N alpha P. ठीक है मैडम? Fine. So, we will see the ratio of energy of two photons of wavelength 2000 angstrom units and 4000 angstrom units. Answer? 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 So, don't feel among yourself, it's a competition. You are about to give the competition in the entire India. Come on बेटा, ये क्वेश्चन का आपका आंसर क्या दे सकते हैं? So, इसका वैल्यू है लैम्डा 1 देगा, lambda 1 is equal to 2000, lambda 2 is equal to 4000, right? So, how the energy and wavelength are related? Energy is equal to hc by lambda. H is a constant and c is a constant. Therefore, I would say energy inversely proportional to wavelength. है क्या ना? Fourth option again, Hemant. Vishal Mukherjee. Yes, your answer is not that clearly visible, but I could say this answer is the accepted. So, E1 by E2 is in the ratio of lambda 2 by lambda 1 is equal to 4000 by 2000 is going to be 2 by 1 is going to be 2 is to 1, 2 is to 1. Your answer is correct. Maunika, perfect. Inversely related. है ना? Clear? So, your answer matches. Very good. Nice. और एक क्वेश्चन है, एनर्जी ऑफ 1 mole of photon has of a radiation wavelength 300 nanometers. What could be your answer? आप करके बताना, करके देना, करके देना. Energy of 1 photon E is equal to hc by lambda. So, energy of 1 mole photon E is equal to Avogadro number into hc by lambda. कर सकते हैं अभी? So, formula is given now. So, Hemant is doing, Maunika is doing, Hirakan is doing, Vishal is doing. Vishal beta, Vishal Mukherjee. So, you are solving along with me. So, let it be wrong, but you have to solve along with me. So, this is what is a practice session. 45 days journey, only practice चलते रहते हैं. Okay, so in this journey of 45 days, you are going to learn very good things, unknown things and known things in a different way as well. Believe me, after this 45 days, you are going to do the perfect. Right, Hemant, appreciation, your answer is correct. Number 3 is the answer, 399 का है. So, simply you plug the value 6.626 into 10 power minus 34 and the H value 6.023 into 10 to the power 23, 6.66 into 10 power minus 34, 3 into 10 power 8 upon value 300 nanometers is converted into meters by multiplying with 10 power minus 9. So that Maunika, you also got 3. So as a result of this, you are going to get the answer in joules. So make the answer in kilojoule per mole, right? So there lies, here you can see energy of 1 mole of photon. So 6.6 into 10 power minus 34, it is 3 into 10 power 8 upon 300 nanometers is converted into meters and multiplied with a mole. You are going to get 399 into 10 cube joule per mole. So 10 cube hata de, kilojoule milega, 399 is the answer. Your answer is going to be correct. Clear, Vishal Mukherjee? Correct. Wonderful. And let us do one more. If the threshold wavelength lambda naught for rejection of electron from metal is 300 nanometers, then work function of this photoelectric emission is. E is equal to W naught plus Ke. W naught is equal to Hc by lambda naught. So the lambda naught is given, है ना? And you are asked to calculate W naught. So you can use this formula, bachcho, directly. I want the answer, the work function. I want the answer. I want the answer. Come on. इसका आंसर क्या होगा? Vishal Mukherjee, Maunika, Hemant. So if you face any issues in the calculation, you please let me know so that I can help you in the calculation tricks also. Tricks and calculation. Now your answer is going to be 6 into 10 power minus 9. Directly you can use W is equal to Hc by lambda naught. Yeah, again 3. Very good. W is equal to H value 6.626 into 10 power minus 34, 3 into 10 power 8, and 330 is given in nanometers, is converted into meters. And on solving so, you are going to get 6 into 10 power minus 19 joules. Any doubt here? Maunika, you are also. Hemant, good. Vishal, wonderful. And any other students got? Yeah. So tricks for calculation. Yes, definitely. I'll give you E is equal to Hc by lambda 6.626 into 10 power minus 34 into 3 into 10 power 8 upon lambda. है ना? I will tell you. And you can go with energy like this, and E is equal to 2 into 10 power minus 25 when lambda is taken in meters. This is one trick. Otherwise, E is equal to 12400 upon lambda when lambda is taken in angstrom units. You are going to get electron volt. You can directly go into that, right? And 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Rather, you can use this. Okay. Vishal Mukherjee, this is the better one. Boxes are given. Hemant, hope you understood this. You can use this whenever lambda is taken in meters, ताकि आपका आंसर मिलेगा जूल्स में. You can use this जब आप lambda वैल्यू एंगस्ट्रॉम में इस्तेमाल करो, एनर्जी वैल्यू आपका मिलेगा इलेक्ट्रॉन वोल्ट में. अब जब इलेक्ट्रॉन वोल्ट जूल में कन्वर्ट करना तो 1 इलेक्ट्रॉन वोल्ट इज इक्वल टू 1.6 into 10 power minus 19 joules. Yes, Divyanshu Dubey. Okay, Divyanshu, I think you attended my previous lectures as well, right? Hemant, good. Maunika, are you getting, yes, are you getting benefit of these shortcuts, right? Divyanshu, are you there in my previous sessions, it seems, right? Very good. Now let's see one more. Answer is 3. And kinetic energy of photoelectrons is independent. And you never claim that atomic structure, the questions are going to be purely numerical, and it is going to be some logic oriented as well. So ready, I want you to give the answer for this. आप आंसर दे सकते हो, मैं कुछ देना है, चॉइस इज योर्स. जल्दी. You want to say D, intensity, kinetic energy. Yes, W naught E is equal to W naught plus Ke. E is equal to H nu is equal to H nu naught plus Ke, and Hc by lambda is equal to Hc by lambda naught plus Ke. When you talk about this photoelectric effect equations, उसमें एनर्जी है, फ्रीक्वेंसी है, वेवलेंथ है, काइनेटिक एनर्जी है, उसमें इंटेंसिटी कहाँ है? इट इज इंडिपेंडेंट ऑन इंटेंसिटी, इंडिपेंडेंट ऑन इंटेंसिटी. सो नीट एग्जामिनेशन में ऐसे आ सकते हैं. So my answer for this question is going to be 4. I want to say some more important points for this. So I want to give you three graphs. Okay, you want to say kinetic energy and intensity. It is going to be independent. Kinetic energy of the photoelectrons, है ना? So the same question graphical, it can be asked according to the graphs as well. And also kinetic energy and frequency of the incident light, you are going to get a straight line on the intercept of the incident light, and this value आपको क्या बोल रहा है? क्रिटिकल फ्रीक्वेंसी और थ्रेशोल्ड फ्रीक्वेंसी. अच्छा बात है ना वाला. एंड और एक क्वेश्चन आपका आने का संभावना है. सो काइनेटिक एनर्जी and incident light frequency, you are going to have A, you are going to have metal B, you are going to have metal C. Okay, so क्वेश्चन आपका आ सकता है ग्राफ के हिसाब से आयोनाइजेशन एनर्जी ऑफ A, B एंड C इक्वल और लेस देन और ग्रेटर देन. अब बोलना है. So one concept, these many questions we are discussing. Okay, so if you consider the metal A is having the least work function, least critical frequency or threshold frequency, so that it will be having the least ionization energy. Understand? Clear? So this is a very important concept. बेस्ड, अरे ये फिजिक्स में भी इस्तेमाल कर सकते हैं कॉन्सेप्ट, है ना. एंड आगे बढ़ते थोड़ा सा. एंड वन मोर क्वेश्चन, द रेशियो ऑफ वेवलेंथ ऑफ फर्स्ट लाइन इन लाइमन सीरीज. फर्स्ट लाइन इन लाइमन सीरीज, लाइमन सीरीज जब आता है ना, n1 इज इक्वल टू 1. डोंट से मे बी कॉन्फिडेंट हेमंत. आई विल गो बैक. C, B, A. C is greater than B is greater than A. Now you correct yourself. Yes, rectified. Now जब लाइमन आता है ना, n1 is equal to 1 and बामर आता है ना, n1 is equal to 2 and it is said that second line, so n2 is equal to n1 plus 2, so that it is going to be 4 and इसका n2 is equal फर्स्ट लाइन ना, इसका इमीडिएट सेल से आ सकता है n1 plus 1. सो ये दोनों का रेशियो क्या हो सकता है हेमंत? ये दोनों का रेशियो कैसे निकाल सकते हैं? आंसर जल्दी, आंसर आंसर आंसर. 4:1 विशाल मुखर्जी. ओके हेमंत आपका, दिव्यांशु दुबे, मौनिका, विशाल राइट्स. Now it is going to be option 3, 1:4 आ रहे हैं, इसका देखना पड़ता है. So using Rydberg equation you can see 1:4. So for alpha line, so this is for alpha line beta, okay, it is going to be 1 by 1 square minus 1 by 2 square, 1 and 2, right. Now इसका बीटा होगा ओके, लाइमन सीरीज में बीटा, बामर सीरीज में बीटा. सो ये दोनों का रेशियो 1/2 स्क्वायर 1/4 स्क्वायर. व्हेन यू टेक द रेशियो बिटवीन दिस टू, ये काट हो जाएगा ना. सो इट इज गोइंग टू बी 1/4. सो दैट 1:4 इज द आंसर. गॉट इट? यस दिव्यांशु दुबे, करेक्ट. So very important thing is, I mixed all the questions in this today's session, and especially for quantum numbers tomorrow I reserved, because of the quantum numbers, shapes of orbitals and orbitals probability graphs and nodal plane, everything will be discussed. So tomorrow afternoon 1:30 everybody get ready for that, right? Now अगले और एक क्वेश्चन आना है. Now the ratio of the radius of first orbits of hydrogen, helium and lithium. It's my favorite question in when. It's my favorite question बच्चों. So the ratio of the radius of the first orbits of hydrogen, helium and lithium. Radius calculate करना कैसे है? Radius is equal to 0.529 into n square upon z. So first orbits का बोला सबका है, so that radius is inversely proportional to z, right? So it is going to be 1 by z of hydrogen is to 1 by z of helium plus is to 1 by z of lithium 2 plus, है ना. Z of hydrogen is equal to 1, helium is equal to 4, lithium is equal to 3. So 1:1/4:3. सुंदर नहीं दिखते हैं ना. You multiply with 6. So that 6 into 1/1, 6 is to 6 into 1/3, it is going to be 6/3 means 2 is to 6 upon 3 is equal to how much? It is 3:2. It is going to be 632. Understand? Correct. Wonderful. Ratios भी मैनिपुलेट करना पड़ता है. Ratios भी मैनिपुलेट करना पड़ता है. Yes, it is going to be 3. Divyanshu Dubey, correct. Maunika is given. Hemant, okay. Vishal Mukherjee, wonderful. And if the shortest wavelength of hydrogen atom in Lyman series, n1 is equal to 1, shortest wavelength means lambda 2, n2 is equal to infinity, n2 is equal to infinity, because highest energy is shortest wavelength. Then the longest wavelength in the Balmer series is, Balmer series में क्या, n1 is equal to 2, and the longest wavelength mean to say least energy, so that it is going to be n2 is equal to 2, 3. He2 होगा ना, z is equal 2 ही लिख दिया मैं, z is equal 2 ही लिख दिया मैं. It is 2. Okay, sorry, जल्दी से गलती हो गया. So आंसर ये, when I calculate 6/2 is equal to 3 ना, या इसका आंसर क्या होगा बेटा, जल्दी. विशाल मुखर्जी, it is going to be 36 x by 5. If it is said that it is x, it is going to be Vishal Mukherjee. This time it is going to be 9x by 5. You cross check the answer once. Monica and Divyanshu, Hemant, come on. Now, Hemant, you prompted me to start the questions now. You have to give the answers as well, right? Now, let's see here. 1 by lambda is equal to RH by z square of n by n1 square minus 1 by n2 square. So, 1 by lambda 1 is equal to, for this one Lyman series ka infinity shortest wavelength ka. So, that it is going to be say x. Okay. Now, it is going to be x. Let's talk about lambda 2. 2 and 3. We have taken as n1 is equal to 2 for the BAM and it is going to be 3. Now, you are going to solve that as lambda 2 is equal to 9 by 5 times of r, right. So, lambda 1 is equal to 1 by r is said to be x. So, 1 by lambda is said to be RH or lambda is equal to 1 by r. So, lambda 2 is equal to iska ulta hoga. So, 9 by 5x. The answer is going to be 9 by 5x. Understand? Vishal Mukherjee, corrected yourself. This is a popular question. This is a very popular question. Everybody take a screenshot of it and you can practice it. This type of things. You are calculating the wavelength and taking the ratios. है ना? Z square नहीं लिया. You have to take the, this is hydrogen atom का है ना. If you take hydrogen, this is helium. You have to take the Z value here. Now you got it, Vishal Mukherjee. So as you are solving along with me in this YouTube platform, I am going to pick you where you have gone wrong as well, right? Preparing subject and preparing questions, preparing for any examination doesn't matter, but you should know where is your mistake. Mistakes भी आपको पता करना है. Next, the first ionization energy of hydrogen atom is E. The ionization energy of helium would be, wow, how? It's a good question. It is all about the Bohr's atomic theory. Huh? It's all about Bohr's atomic theory. Jaldi, फटाफट. Who will give the answer? Waiting for your answer. Ionization energy. Ionization energy is equal to plus 13.6 into Z square by N square. Z square by N square electron volts. Mind it. इलेक्ट्रॉन का जब जितना एनर्जी है उतने एनर्जी अगर दे सकते हैं तो पॉजिटिव, इसका एनर्जी जीरो हो सकता है, ये कम से कम एनर्जी है, दैट इज कॉल्ड आयनाइजेशन एनर्जी. हाय रिफत, ये ऑप्शन नहीं है पर ओके, यू वांट टू से ऑप्शन 1. ओके, विशाल मुखर्जी, इट इज 4E. नाउ इट इज गोइंग टू बी विशाल, योर आंसर इज परफेक्ट. यू कैन सी ionization energy is equal to plus K into Z square by M square. Ionization energy of hydrogen is equal to ionization energy of helium is equal to Z square of hydrogen upon nth shell of hydrogen square into nth shell of helium square upon Z of the helium. So, first shell से atomic number 1 by 1 square into First shell say helium, it is equal to 2. So it comes to be 1 by 4. So that ionization energy of helium is 4 times the ionization energy of hydrogen. है ना? Helium plus का helium atom का नहीं है, because these calculations are strictly used for hydrogen and hydrogen like species. बच्चों समझ में आ रही क्या? चलो अगर डाउट है ना तो पूछ दम. Monica, I couldn't see any of your messages in this frame. You said it is 4. It's correct. It's correct. Wonderful interaction. Wonderful interaction. Now, अगले और एक क्वेश्चन है. A hydrogen molecule and helium are moving at the same velocity. Then the ratio of the de Broglie wavelength. Okay, lambda is equal to h by mv. Okay, and the ratio of these wavelengths are given as h by mv is equal to lambda 1 upon lambda 2 is equal to m2, there should be a gap, m2 v2 upon m1 v1. It is given as same velocity, so the volume is cancelled, and hydrogen atom, hydrogen molecule, its velocity, its mass is going to be 2, and helium atom, its mass is going to be 4 by 2, so 2 is to 1. So you are going to get the option 1 is the correct answer for this. Any doubt? Any doubt? Answer given already. Answer given already. Now assertion reason. आजकल नीट एग्जामिनेशन में assertion reasoning टाइप क्वेश्चन बहुत हलचल चल रहा है. Definitely you are going to get 5 assertion reasoning questions out of 45 questions, and match the following also, statement 1, statement 2 also, reasoning also. So you should have that particular assessment when you preparing for an examination, है ना? जल्दी. So the kinetic energy of the photoelectron ejected increases with increase in intensity. Kinetic energy is independent on intensity of the radiation. Kinetic energy and intensity, है ना? Therefore this is not correct. Therefore this is not correct. Okay. So मैं क्या बोलना चाहता हूँ यहाँ पे? Increase in intensity of the incident light decreases the rate of emission. अरे इंटेंसिटी इंक्रीजेस ना, रेट ऑफ फोटो इलेक्ट्रॉनिक एमिशन इंक्रीजेस. ये भी गलत बात है, ये भी गलत बात है. ओके, फोटो इलेक्ट्रिक करंट एंड इंटेंसिटी, एज इंटेंसिटी इंक्रीजेस फोटो इलेक्ट्रिक करंट इंक्रीजेस. सो बोथ आर के इंडिपेंडेंट ऑन इंटेंसिटी. करेक्ट है मंथ? परफेक्ट. सो द आंसर फॉर दिस क्वेश्चन इज बी. आंसर फॉर दिस क्वेश्चन इज बी. Now one more question. Energy for helium plus is minus 54.4 electron volts. The energy E2 for the helium would be, I mean to say E1, here it is E1, first shell, and this is going to be second shell. This is going to be second shell, right? Who will give the answer? Who will give the answer? Energy is equal to minus 13.6 into Z square by N square, right? So both are helium plus, na? So this is constant. Both are helium plus, na? So this is constant. Okay, I want to say E is inversely proportional to N square. E1 by E2 is equal to N2 square by N1 square. So E1 कितना दिया? Minus 54.4 is given. You are asked to calculate E2. It is going to be 2 square by 1 square. Solve it. E2 कितना मिलेगा? E2 कितना मिलेगा? 54.4 by 2, 54.4 by 2, 4 by 4, is equal to 13.6. Right, it is going to be 13.6b. You have given ये आंसर कैसे मौनिका? It is going to be B. ठीक है, 13.6 इलेक्ट्रॉन वोल्ट. कहाँ गलती किया तू मौनिका? Where did you go wrong? Hemant given correct answer. Vishal Mukherjee is given correct answer. Wonderful. It's B. Yes. Now the ionization energy of the ground state of hydrogen atom is this much. The ionization energy of electron its second orbit would be. Solve it. Solve it, solve it, solve it. Already 30 questions you already completed along with concept we did in class. Okay, I'll give you the answer. Hemant, yeah, you want to say D? Okay. Monica, आपका है हेमंत. You are lagging in calculation और क्या? विशाल कर रहे हैं ना, आप भी कर सकते हैं. थोड़ा सा पुश करना है, मोटिवेशन देना चाहता हूं मैं. हेमंत, you want to say D? So what I say here it is also D. Minus 5.45 into 10 power minus 19 kilojoules. Now that you can solve it. Yeah, that you can solve it. Now the radius of second Bohr orbit in terms of Bohr's radius on the lithium 2 plus is. It is also a famous question from the Bohr's atomic theory. Get ready. Azim Sharif. Azim Sharif. Monica, you want to say D for this और पिछले क्वेश्चन का है? So Vishal, that's a wonderful interaction on the YouTube channel. So everybody, you want to say B, Vishal? Okay, perfect. Your answer is perfect. Okay. Let's see. Here it is shown that B. So पिछले क्वेश्चन का है, कोई प्रॉब्लम नहीं. So when you give the answer and be in line. Okay. So for this you want to say B. When I say radius is equal to n square into 0.529 upon z. 0.529 जो है ये नॉट मांगना के बोला हेमंत. So this is the radius of the electron in nth shell is equal to 0.529 into n square by z. ये जो a naught है ना, this is said that a naught. Are you getting or not? So that for second Bohr's orbit of lithium n is equal to 2, z is equal to 3. उसमें ये a naught डालो. So z square into a naught upon 3. दिखाई दे रहे क्या बेटा? So 2 square into a naught by 3. 2 square is 4a naught by 3. It is going to be 4a naught by 4a naught by 3. So it is going to be B. Clear? अगर कुछ डाउट है ना तो पूछ लो. मोनिका, आजिम शरीफ, यस इट इज करेक्ट. अजीम फिलहाल कहाँ गए तो? Your answers good. Vishal is doing good, and Hemant, he is also doing good, cleared. And Such a nice reciprocation, Hemant, good, appreciated. And Monica, yeah. Now, or a question then? Yes, it is going to be this one. The ionization energy of helium is 19.6 into 10 power minus 18 joules per atom. The energy of the first stationary state of lithium 2 plus. So this is a simple calculation part. Just take the ratios. काटना है बस. Got it? आंसर कौन दे सकते जल्दी जल्दी जल्दी. और आंसर इज गोइंग टू बी डी minus 4.41 into 10 power minus 17 joule per atom. ये कैसा निकलेगा? It is ionization energy is equal to minus G1. So for the helium that is given minus 19.6 into 10 power minus 18 joule per atom. Okay, it is given here, and the ratio of the first helium and first lithium is going to be Z helium square upon Z lithium square. That is going to be 2 square upon 3 square, 4 by 9. And minus 9.6 is the value there. E of lithium you have to calculate, that is 19.6 into 10 power minus 18 into 9 by 4. So you are going to get minus 4.41 into 10 power minus 17. Got it? Any doubt? Any doubt? Got it? Clear, Monica? And last question of the day. Similar type of questions. If the radius of first Bohr orbit is A0, the Broglie wavelength of an electron revolving the third Bohr orbit. Wow, it is connected with Bohr's theory and the de Broglie concept. Hemant, we are connecting to one concept to another concept. अच्छा लग रहा है क्या? अच्छा लग रहा है? विशाल, all right, Monica. Everybody give an applause with a fiery emoji and thumbs up in the chat box. So हमको भी खुशी लगेगा. हम लोग बच्चों के लिए कुछ भला करने का कोशिश कर रहा हूँ. बस आप चार्ट बॉक्स में थोड़ा सा एंकरेज देने तो हमारा एनर्जी भी बढ़ जाएगा, है ना? So the quality of the questions that we are giving and these lectures and these questions, what we are doing, this much service we are giving to the students simply for the free of cost, है ना? Free of cost. So get use of this. And coming to this, up answer, anybody can please give the answer, please give the answer. So मैं आंसर दूँ आपको, Monica? Yeah, coming to the answer is going to be 6 pi A0. कैसे देखो, radius of the third shell, you can see third Bohr orbit is equal to A0 n square by Z. A0 Z is equal to 1. A0 into 3 square is equal to 9 A0. है ना? Very good. And 2 pi r is equal to n lambda है ना? So 2 pi r value कितना दिया? 9 A0 is equal to 3 lambda, because क्योंकि एक shell में, third shell में है lambda. So that lambda is equal to 6 pi A0. Simple two concepts are being clubbed over here. So today we discussed a huge concepts like Bohr's atomic theory, de Broglie concept, photoelectric effect, quantum nature of light, everything. And today we completed half of the questions from the atomic structure, near about 40 questions we discussed. And in the tomorrow's class, total quantum mechanical model of atom, Schrodinger wave equation, and shapes of orbitals, quantum numbers, electronic configuration, magnetic movement, everything. So please like this session, share with your friends, and subscribe to Infinity Lane YouTube channel. Okay, thank you very much everybody. A thumbs up and fire emoji to say bye bye, and signing off, Suresh, Faculty of Chemistry. Say bye.